Go.
All right, in this next installment here, we're going to check the XR100's alternator coil resistance, which is the power source in the XR100. Here's a fully assembled XR100 stator. Here's one that's been taken apart, so we can do just the resistance on that one coil. So we're looking for between 676 and between 0.858. So we're going to go to the 200 scale, and we're going to check for resistance between the output of the windings and ground. We're going to be looking for somewhere between 0.676 and 0.858. So I have 0.8 right now. 0.8, you want to show them the results? The meter? Oh, down to 7. Between 676 and 0.856. We're in the market right there.
Can you show them where you're doing the connection?
I'm doing the connection right at the end of the windings.
Yep.
Notice I don't have the points or a condenser or anything else in the series. I'm just checking the state of the wires. I'm checking the condition of the windings here. So that is within spec. I got 0.7. That is definitely between 0.67 and 0.85. Let's see, the Nighthawk pulse generator. Now remember, pulsars, we could test these two ways. We could test these statically, which we're doing right now, or we could test them dynamically. When we test these dynamically, we need a peak voltage reading, the rate pair adapter, to get a peak reading out of it. So we're going to check these statically. We're going to check them for ohms. And our pulse generator ohms is 330 ohms plus or minus 10%. So I'm going to go, this side here has the 2 blue wires, this side here has the 2 yellow wires. So we're going to check across the 2 yellow wires first. Back probing so I don't hit the terminals. And I have let's see, I got to be on the 2000 scale because it's over 200 ohms. The test is 330. So I got 344 ohms out of here. The spec is 330 plus or minus 10%. So I'm definitely well within my ohm reading for this. That's for one signal generator. Now let's check the other side. There we go. Got 335 on this one, which is definitely within 10% of 330. So we definitely have a good pair of pulse generators here. Now, if I didn't have the spec for this, and I knew both of these units were the same thing, not even knowing where the book was, forget where the specs were in it, I could go across these 2 pulse generators and say, okay, I've got X amount out of this one, now I've got X amount out of this one, are they compatible? Because if I have 330 ohms in one of them and 10 ohms in the other one, I know that one of them's faulty. I may not know which one it is, but I know one of them's bad. And by the way, I can't replace one of these. You have to buy a pair of them, okay? So no matter what you do, if you have one of these bad, you have to replace them both. Just like on the RMZ, if you have a bad crank position sensor, you have to replace the stator. It's part of it. It's all one unit, okay? So we've now done pulse generator statically, because we don't have an engine to turn it over and test for output. So we did the resistance check. And earlier, we had discussed spark plug caps, spark plug cap resistance on a normal, everyday normal spark plug cap. We're going to go across input to output. We're supposed to have a certain amount of ohms. It's supposed to be between 375 to 6.25 K ohms. So we're on the K ohms reading right here. We're going to check across the terminal, and we have 4.62 K ohms. That falls directly right in between 4.62 K ohms. It's right in between 375 and 6.25 K ohms. So this is definitely well within spec. This has a resistor inside of it, which can fail. When you unscrew the little piece inside the cap here, there'll be a little resistor in there. Those resistors can overheat and cook and give you a no spark situation. In fact, that was what was wrong with that Mr. 50 that down on Water Street. You need a spark plug cap, okay? And they sometimes make you crazy. Now, we had discussed earlier the use of a buzz box, okay? The buzz box is an object that tells you when your points are open or closed. Now, I just turned this on. I've got one lead connected onto my points wire that comes out. The other lead is just connected onto a ground, anywhere on the ground. Now, anytime those points break, it's going to tone. So when I push the points open, it buzzes. So when we're setting the timing on this, as soon as it gets up to the F mark, the points are going to break. Or when it gets on the other side of the F mark, the points are going to close. So I'm going to be looking for a reference mark on the engine case and on the flywheel. As the flywheel turns by it, we're going to be looking through the window on the flywheel so we can actually look inside. And while the flywheel is turning, it can open or close the points, depending on what needs to be done at the time. If it opens or closes. Is the other flywheel there? The flywheel. Points are open. Points are closed. Because there's no flywheel in here, no crankshaft holding it even, so I can open and close the points just by moving it back and forth here. Then your F mark and your T mark. F is fire, T is top dead center. When this spins around, it gets to a certain point,
Thank you.
it's going to, you're going to be able to open or close the points to make that appear, to make the buzz or the break of the points turn before the F or after the F. Then you're going to dial the points in by opening or closing the gap up to make sure they break right on the F mark, which is what the buzz box does. It does it in 3 ears, so you don't have to look. You can be looking at the points and not looking at the marks. You can hear it buzz back and forth, and you can be looking at your marks while you're setting your point gap. It's a pretty cool way of setting these up. Like I said, my dad made me, when I was a kid, a flashlight that did the same exact thing as this, but instead of buzzing, the light turned on, or the light shut off by connecting the wires here. So I had continuity, so it turned the light on. Or when I got on the other side of the F, the points broke and the light was off. So my dad made me one of these, like I said, when I was a kid, with a flashlight, because that's what farmers do. They make things.
Yeah.
Okay, that's a quick ignition, brief summary. Points open and close. You adjust the points of the buzz box. The pulse generator throws out a signal that the ECM or your igniter gets. And that changes the timing electronically inside the box. With this style here, this changes the timing inside the box itself. Where this style here has a mechanical weight advancer unit, where the more primitive style, like the lawnmowers, have no advancer unit whatsoever. And these, like I said, have kind of a flat power output, like a lawnmower. Where these here have like more of, I want to say overhead, but it just pulls longer and harder because the timing can be advanced and retarded to make it run better.
More dynamic.
At higher RPM, yes. This is the next evolution. Primitive, next step, and of course, we've evolved onto the CDI or pointless ignition, and they really boogie, so they can change the timing whenever they want to. They can pick their own ignition curve. All right?